So in procedural versions of set definition, let X and Y be subsets of a universal set U, and suppose X and Y are elements of U. So we see here the identity that X belong to the union of X and Y if and only if X belong to X और X belong to Y. तो यहाँ पे हम तमाम वो डेफिनेशंस पढ़ेंगे जिनको हम किसी भी प्रूफ में यूज़ कर सकते हैं और इन डेफिनेशन को हम सेट ऑपरेशंस के लिए भी इस्तेमाल कर सकते हैं. और इसी तरह सेकंड नंबर पे हमारे पास है X belong to intersection of X and Y if and only if X belong to X and X belong to Y. Here the connective is used and, so X must belong to capital X and X must belong to capital Y. So in third property we see here the difference of two sets. So we say X is a member of difference of two sets if and only if X belong to capital X and X does not belong to Y. If X belong to X, then X does not belong to its complement and vice versa. On the fifth number we see an ordered pair XY belong to the Cartesian product of X and Y if and only if X belong to X and Y belong to Y. So जब भी हमें कहीं पे किसी भी थ्योरम में ये इस्तेमाल करना पड़े तो हम इनकी जो डेफिनेशन है वो इस तरीके से यूज़ कर सकते हैं. Some properties of sets. First theorem is inclusion of intersection. So here we see that for all sets A and B, A intersection B is contained in A, or similarly A intersection B is also contained in B. So intersection जो है वो part of A and part of B है जो कि similar part है. So that must be a subset of A and that must be a subset of B. The second property is inclusion in union. So for all sets A and B, A is contained in the union of A union B and B is contained in A union B. And these can be seen intuitively that the definitions are true, since in A union B we have both the elements of A and B and the intersection part, so A must be a subset of A union B. Likewise, the third property is a transitive property of subsets. For all sets A, B and C, if A is contained in B and B is contained in C, then A is contained in C. So this is an obvious thing to see here कि अगर एक सेट जो है वो दूसरे सेट में पूरी तरह कंटेन करता है और दूसरा सेट जो है वो किसी तीसरे सेट में कंटेन करता है, जो पहला सेट होगा वो लाजमी तौर पे तीसरे सेट में कंटेन करेगा. Now we see here some proofs of these properties. For the first part we see here we need to show that A intersection B is contained in A. So we choose an element from A intersection B and show that that element is present in A. That's how we show the subset relationship. So we suppose X is an element in A intersection B, and then we need to show that X is in A. To say that X is in A intersection B, it means that X belong to A and X belong to B. And this allows us to complete the proof by deducing that in particular X is in A. और यहाँ पे अगर हमें पता चल जाए कि X A में भी है और X B में भी है, तो इस बात से हमें ये अखज़ करना, डिड्यूस करना इजी है कि X जो है वो A में भी है. और यहाँ पे जो फॉर्म ऑफ आर्गूमेंट यूज़ की जा रही है दैट इज़ नोन एज स्पेशलाइजेशन, जिसमें हम P एंड Q अगर गिवन हो तो हम उसमें से डिड्यूस कर सकते हैं कि P इज़ ट्रू. सो यहाँ पे ये रूल ऑफ इन्फ्रेंस जो है ये यूज़ किया गया है. और इसी तरीके से बाकी जो इसकी प्रॉपर्टीज़ हैं उनको भी सॉल्व किया जा सकता है, इसी तरीके से देखा जा सकता है. लेट ऑल सेट्स रेफर टू बी सबसेट्स ऑफ a universal set U. Here are some set identities. First is commutative law. So this is by the change of places of A and B, there is no difference in union and intersection. Similarly, in associative law, when we take union of three sets, we can take the union of first two or we can take the union of last two, and it will not affect the equality. And similarly is the case for intersection. And the third property is distributive laws. So in distributive laws we have three sets A, B and C. So this is the distribution of a union over intersection. So it will be expanded as A union B intersection A union C. And similarly this is intersection over union. So in this distribution we see we get A intersection B union A intersection C. And in the fourth identity, for all sets A union phi is equal to A, and A intersection universal set, this U stands here for universal set, we get A. Next is complement laws, and we see here A union A complement is a universal set, and A intersection A complement is an empty set. Now we see double complement laws for all sets A. If we take a complement of a set, if we take a double complement of a set, we will get the original set. Next property is idempotent laws. For all sets A, if we take the union of A with itself, we get A, and we take the intersection of a set with itself, we get that set. In eighth property, we see a universal bound laws. For all sets A union with its universal set will gives us universal set, and A intersection with phi will give us phi, which is an empty set. The ninth property is De Morgan's law, and in De Morgan's law we see that we are taking the complement of union of two sets, and on the right hand side section of complement of two sets. Similarly, in B part, when we take the complement of intersection of two sets, it will be equal to the union of complements of both the sets. Now we see another law, which is the absorption law. So for all sets A and B, A union A intersection B is equal to A. Similarly A intersection A union B is equal to A. यहाँ पे जो ब्रैकेट्स हैं उसमें इंटरसेक्शन का निशान है और बाहर जो है वो यूनियन का निशान है, और ये बिल्कुल डिस्ट्रीब्यूटिव लॉ की शक्ल है। जस्ट यहाँ पे जो हमारे पास सेट्स हैं वो सेम हो चुके हैं। सो ए और जो ब्रैकेट में सेट है और जो बाहर सेट है वो सेम हो चुका है, तो वही सेट जो है वो हमारे पास इक्वलिटी में आएगा। और इसी तरीके से यहाँ पे भी हम देख सकते हैं। 11th property is complements of universal set and phi. So the complement of universal set is phi and the complement of phi is equal to u. Now we see set difference law. For all sets A and B, A minus B is equal to A intersection B complement. So here A minus B says that we are taking elements of A which are not present in B, and here we see that after taking the complement of B we get all the universal set except B, and we are taking the intersection of that set with A. So both have the same meaning.